Tagliatelle, stiamo per cominciare. Hi everyone, we are going to begin the presentation of Theune about batou. So please switch off your cell phones and enjoy.
All right, thanks. Welcome. I'm going to start my talk now. We've got 45 minutes before you guys get coffee, and I didn't have coffee, so I'm going to try to be on time. But it's a lot of stuff. So that's me. You can call me Theune. That's my Twitter handle, and you can get me there. That's my company. Quick plug. We've been around since about 2000, and since then we've been part of the Python community. And apart from actually whoring some PHP in 98 and 99, we've been good people, I think. I wasn't legal back then, so we're happy open source developers. And so if anybody of you should be interested in a job or something, programming, sysadmin, DevOps stuff, then come and talk to me. This is what I actually work on. It's called the Flying Circus, and that's our operations as a service product. So where you get managed virtual machines and managed services, and with a twist that we think could be very nice. But all right, enough of the shameless plugs. Let's get started. Let me show you what you're going to learn, I hope. First, automating deployments is really hard. And so you need to approach it with enough attention to detail. And one thing that is going to help on part of the solution is something called CONVERGENCE, and we'll see why. And the third question, hopefully what you learn is that how does that all work with batou? And let me start with giving you some perspective. The technical items that I'm going to mention, they might seem very meticulous, very detailed, very nitpicky. But if you don't do that, that's going to bite you. Basically, if you don't do that, something like that happens. That's like what operations feels like sometimes. And I mean, I guess it's not that bad. I mean, it looks more like that. So yes, it actually is bad. Complex projects, they all have the tendency to accumulate a lot of details, and then at some tipping point, they become actually complicated. And we strive to simplify those things over time, but at any given point in your project, you have to be ready to deploy something, right? So you know that you've got all this garbage in your backyard, and you should make it better, but well, you've got to deploy something right now, and yeah, you're gonna make it better tomorrow because you can't gold plate it today, otherwise you don't have anything in production. So we're going to have to deal with that complexity, even if you don't like it, and hopefully we don't even make it worse when we deal with it. When I talk about service deployment, I pull out this layer approach. It's from a book called Practice of System and Network Administration by Limoncelli and Strata and another person I forgot. It's a really good book. It's really big. It's really good to gain some muscle if you carry it around. So this is basically about separation of concerns, right? It makes sense to structure these things, but these layers are not necessarily divided in the same way at every party that you're going to meet. They also tend to overlap. Obviously, you can do some things with Fabric that you can also do with Puppet, and Puppet can do things you can do with Fabric, and it all comes down of where you actually separate things. But for me, it helps a lot to keep that in mind, what these layers are. So let's start at the bottom. The bottom is provisioning, and that's like a really harsh environment. There's no operating system there yet. Hardware and BIOS is really horrible to work with. So what you do there is you do something that's called Just Enough OS, sometimes abbreviated as GEOS. Something that gives the machine enough operational capacity, operational ability to then take over, have your regular tools take over, that you actually have an operating system on there. So the next layer on there would be system configuration, and from our perspective, system configuration means taking many machines and configuring them in a homogeneous fashion, maybe parameterized, that you know, okay, These are all Postgres servers, and Postgres servers are always configured the same way, but this one has more RAM and this one has a little bit less RAM, but basically they're all the same rules, and you don't configure actual databases on it. That's something where we have the service deployment layer, where we say, okay, let's take a couple of these machines that are configured and then individualize them and make them perform a specific instance. Welcome. Right, so service deployment to configure a specific instance on top of a set of pre-configured machines. And that could be like the staging environment of your website or the production environment. These would be instances of that service. And so separating that also for us means that not everybody has to have root. I mean, system configuration obviously needs to have access to the system as root, but when you think DevOps, that doesn't automatically mean that everybody has root, but that you have the ability to actually communicate and work together. So for us, actually, we try to establish something like a UI between the system configuration and the service deployment layer, and then have people talk about that. Hello? So since we've been around for a while, since 2000 and a little bit more, we did all kinds of things for making deployment better. I mean, most of you probably remember FTPing some files just over to a web server and that being your deployment. And in 2003, I come from the Zope world. We gained something called the MK Zope instance, and actually it was the other way around. We first used Bash then to configure Zope instances, and then we gained some utility to set up these instances, but these were one-off things. You couldn't check them in. You always had to redo that. And then we gained something called build out, which is quite nice, automating, making repeatable Python environments, Python environment deployments. You can check those in, you can run them, and you can combine that with virtual env quite nicely. But that only works on a specific machine, right? And so Fabric, all of you know that, right? Who does not know Fabric? Okay, who knows Fabric? Okay, thanks. That is actually. So we went to Fabric, so we were able to do multi-host things, but that also became really, really complicated. And we're going to see why that became complicated in a minute. So services are complex, and obviously due to that, deployments will be hard, but that's not what I mean when I say deployments will be hard. And we've got a history of approaches that are becoming better and better and better. Then again, we're also making the problems harder and harder and harder. I said convergence will be the answer, so now what's the question? If you don't remember anything from this talk, or if you have to pick one thing, pick what I'm going to say in the next 3 slides. That's going to be the important part. Everything else, you can leave, you can get coffee, whatever. The next 3 things, that's important. If you think about deployment, we're going to make some changes on a target system. That usually involves creating directories and files and putting stuff there, maybe changing the mode or things like that. And you could write that with Fabric, obviously, but I'm trying to keep it simple. And so this is called forward-driven. It will always perform the same steps independent of what the system state is, and it will stop in the middle when it encounters an error. So let's look at the specific problems that we have in there. First, let's change the title. This isn't simple. This is simplistic, like that. So what do we see? First, the directory up there, that might exist already, so that would error out. Something else might even exist at this location already. And when it errors out and you start it again, you were maybe in the middle of something, and then you can't just restart because, well, you just created the directory, so if you start it again, it's going to stumble over that. That doesn't help. And something else is that we keep changing these things all the time. And that can actually, first, that makes it unnecessarily slow. If you don't think you're just writing 4 bytes, but we might be unpacking huge archives, you might be doing huge compile tasks or whatever. So you don't want to do things that you don't actually have to do. And because this also can, down the road, trigger other things to do unnecessary work on top of that. So if you rewrite a file, the modification time changes, and if make comes around, it's going to stuff like that. So let's try to make this correct. So this is what it would look like if we would make it convergent, I think. The first thing you can see here is, even if it might be correct, it becomes horribly complicated. You've got to add a lot of checks, and you're like, okay, if this exists, then then throw it away first, and yada yada. That's like really, really hard. But what does convergent actually mean? And I have to quote this. This is from Wikipedia, from the CF Engine page. Convergence means that each change operation made by the agent should have the character of a fixed point, obviously. Rather than describing the steps needed to make a change, the language describes the final state in which one wants to end up. The agent then ensures that the necessary steps are taken to end up in this policy-compliant state. Thus, it can be run again and again, whatever the initial state of the system, and it will end up with a predictable result.
So the word you're looking for is everything is idempotent?
Nope.
No?
No. I'm leaving out idempotent here on purpose. Convergence is one way to approach an idempotent system. So looking at that, this actually becomes bad. Looking at this at the definition, we already see that we are not specifying where we want to go. We are still telling the system do this and this and that and this and that. And this is horrible, even though it fulfills most of the behavior that a convergent system would have. So if I want all of this to become convergent, and I would also like it to be more expressed more succinctly. If I can make a wish, that's what it would look like. So that way, I tell the system I want a file in a specific directory with that content and that mode, and I want it to have the parent directories created if needed. This is pretty declarative, and I don't tell it anymore, do this and that, I just tell it where I want to go. So the question is, looking at the previous slide, how do we actually get there to make this thing actually become real? So this is the implementation of the file component almost as we use it. It's a little bit simplified to let you understand it easier on these slides. The first part of the solution is divide and conquer. You probably know that. So we call those things components. The file thing, it's called a component. And to avoid putting spaghetti code about the directory management and the content and the mode management all in there, we split it up. We say, well, there's more components. There's a component that manages the presence of a regular file, and there's a component that manages the mode of a file, and there's a component that manages the content. And so the file component actually becomes pretty simple that way, not even doing anything. That's really, structurally, that's exactly what the file component in batou does and looks like. So the configure method is there to compute target state. You're not allowed to touch the system. You're not allowed to look at the system because this might be computed anywhere and it might run multiple times. Then there is the composition operator that creates a tree of components. So it attaches these components as subcomponents of the file. And third, it's important to watch the order. Within a component, all the subcomponents are then managed in the order that you call the composition operator. So how do we actually do some work? So this thing only delegated. That's an important part, but it didn't actually do anything. Let's pick the presence component. Again, it's a component. There's this name var thing. The name var is if you call the component, if you instantiate it, you can have one parameter that you don't have to specify a name for. This is a little bit like in Puppet. If you know Puppet, then you always have one parameter that you don't have to give a name for. And this just, the name var specifies the attribute that this parameter is going to end up in. So this component expresses that a certain path should be a regular file, and whether we care for creating the directory hierarchy or not. This is to allow specifying whether the responsibility of creating these directories is with us or with somebody else. So as I already said, the configure method, that's going to run anywhere. You can't expect this to run on a specific server. It can run on all servers, can run on your local machine. In contrast, the actual work happens in these two methods, in verify and update, and these are actually run on the target system affected. And so these can read and modify the state. Verify is run after all the subcomponents are done. It determines the target state. It determines whether the target state has been reached already, and if not, it raises an exception to signal that we've got to get an update. And if that's the case, then the update method will be executed only if needed. Only if we know we need to change something. We're not at the point where we want to be. And also, we can combine that with delegating even further. So we said we're gonna look at the leading directories, and we don't do any actual work regarding the leading directories. We say again, hey, let's push this down one further. Let's hand that over to another component. Let's have one more look at how this works. So we're going down in this component hierarchy, and I hope you start seeing a pattern. Verify and update. They work nicely hand in hand together with configure, and they make very, very simple components. In theory, I could have even made this leading thing a recursive component. I just chose to stop at this point and make it this way. I could also have said configure directory, remove one part, throw it in there. This is just laziness from my perspective, but it works very well. The nice thing is that you can write your own components very easily. You can just ignore all of the standard library that we have in batou. You can just do your own thing. So whatever works for you, you can just go around this if you don't like it. All the methods are optional. You see that there's no configure method in here. Doesn't have to, doesn't do anything. But if you do verify or update, you should better provide both. Verify in the default implementation just doesn't do anything, so it's never going to call update. So you will have to implement these always together. And there's one interesting pattern that that stands out is when you enter update, you know that you're not at the state where you should be, so you can just make one thing that cleans up whatever is there. This is one particular helper function, the ensure path non-existent, that we need a lot for this low-level structures. And it doesn't care for is there a symlink there, a broken symlink, a directory, a regular file, and FIFO or whatever. It just ensures that there's nothing there, and then the code next to it becomes really, really simple. All right, so now we've seen a system that supports convergent behavior. Obviously, we can't completely handle all unexpected and arbitrary system state, but it's becoming easier to abstract that away. Things that you probably won't be able to automatically deal with is things like file system corruption or asteroids crashing into your data center. But pretty much all the regular things that can go wrong or that can be weird in a system that you can counter. And you don't have to repeat yourself all the time. Being lazy, actually, like only running update when needed, actually gives you two things. First, it avoids unnecessary pressure on the systems, unnecessary work being done, and it implicitly gives you a resume. Because if something goes wrong and batou exits, and you start it again, well, up until the point where you were, suddenly all the verify methods will say, that's already good, that's already good, that's already good. You've got to start here. You've got to do this. And so that's actually two birds with one stone. And components are the magic sauce that actually feeds all that. My personal goal when I was working on this was to have something like Puppet's DSL to describe these collections of resource states that the target system should have. But I wanted to avoid having a separate language where the implementation of how to actually do that and how to describe what I want separated. And the configure, verify, update cycle together with the hierarchy of components actually allows you to always go back and forth between these two areas, implementation and resource description. And you can always refine what you do even further down, break it in smaller chunks so that the convergent behavior still can hold up and is understandable. So this is really a very generic data structure. You can use it to do pretty much anything. It's just accidental that we use it for this. And basically, it's just there to allow you to factor your code easier and make complex things out of simple things. All right. Now that you've seen the core data structure, I'd like to go through a couple of the design influences, the values that I have in mind when I work on the tool itself. That should explain a couple of the things the way it is. First, I want deployments to be single command. I always want to just say, deploy production. Go ahead, deploy staging, deploy my local thing. As soon as you start adding one more, when you have to, if you know batou and you have to write a README, how to do the deployment, you're doing something wrong. If a deployment worked yesterday, it should work today as well. I think that's obvious. And it should result in exactly the same setup. This is something that, Hinek, where are you? There, you're right. You're absolutely right. Simple. Make it simple. The complex service deployments, they're bad enough as they are, and we don't want to make them any more complicated. We especially don't want to break expectations about existing components. So people who are experienced with things like Nginx or others, we don't want to break their expectations. All right. This is one of the reasons why convergence is so important, entropy. The machines that are sitting out there, they're going to gather garbage over the time. Somebody's going to leave a file somewhere. Somebody's going to make one manual adjustment to a config file that is not managed. And so you can't expect to actually maintain a perfect environment over a long period of time. So I want to be able to deal with that, actually. I don't want to have to actually rebootstrap all my virtual machines all the time because I can't deal with runaway changes. I want stuff to be readable. I want to avoid having large blocks of mechanical code. I want code that actually communicates intention. And when we actually find a specifically nice way how to deploy something, whether that's supervisor or Postgres or something else or integrating with things, I want to reuse it. I want to be able to take stuff that we've done in one project and move it over to another. I want to avoid that we actually know how to do a good deployment, but don't do it because it's so hard. That should be something. That should be a thing of the past. It should be pretty platform independent. I mean, the service model itself doesn't make a lot of assumptions, right? This whole data structure doesn't really talk about Unix, Windows, or whatever. And obviously, specific components like the file with symlinks, that's something that's bound to POSIX platforms. And then you notice that BSD and Unix and Linux, they're a little bit different, and you've got to deal with that. But on specific levels, I try to not introduce platform limiting things. I also want you to be able to actually deploy a service. Do you need a glass of water? We've got some water there. Sorry. I want to be able to actually deploy one service on multiple platforms. I want, as a developer, to deploy it on my Mac and or using Vagrant, and I want to push it to our flying service, Circus, and then maybe over to Amazon. So that should also be something that your model can actually implement, being platform independent. Well, we rely on Python kind of as a platform there, and I don't really like Windows, so I don't do anything to actually support it. I also try to not make any assumption about your service. I mean, I'm deploying web applications with this and all stuff around it, like HAProxy and Nginx and MySQL, etc. But basically, all the technology in there is not bound to that and should not be bound to something like that. I think that if you can do it as a system administrator on a console, then you should be able to do it with batou. And I don't want additional runtimes. There are quite a few tools that that will either hook into your application. You've got to do something as the application developer to work with the dynamic features that these things have. They've got nice properties on top of actually deploying something. They can be very dynamic, but then it drives the complexity of your application up, and I don't want that. So this is kind of a creative limitation to put myself under pressure to find interesting ways to use existing stuff. And I want your model to be useful in a continuous way. I want it to be used both for initial deployments, single command, and for updates. That should always be the same thing. You shouldn't have to do different things for setting stuff up initially or maintaining it later on. And this is kind of obvious. I want minimal downtimes. I don't want to take components down when I don't have to take them down, and I want to be fast, especially if nothing has changed. If nothing has changed, I just want to press deploy again and just see the log output to say I didn't change anything. Actually, everything was good. All right. So these are a lot of goals that I have in mind, and they're sometimes conflicting, and I'm not smart enough to make all of them work together all of the time. But this is basically what guides me. Let's get practical. I'm going to show you no complete setup, but I'm going to give you a couple of excerpts of what specific things look like when working with batou. We've got a tutorial and I'm working on documentation, so if you actually want to check this out, then the documentation will be the point to start. Just in case you don't know, this is actually batou. He's one guy from a movie called Ghost in the Shell, and I picked him as the name giver, as a pun on puppet, because he's got big guns and he's hunting the puppet master. Okay, so what do you need if you want to use batou? Batou itself is written for Python 2.7, but whatever you deploy does not need to have anything to do with the Python version that you're using for deploying it. This is really that's going to be the Python version you're writing your model code in. I expect virtualenv to be around, especially when deploying remotely, and Mercurial as the version control system for checking in the model code for the deployment. This is just a convenience for me to make it possible to use SSH and push your code over to the other machine without having to do too many hoops. Yeah, and SSH, but that's basically it. You don't need much else. There might be specific components that have other requirements to actually work, but that's for the basic system. Okay, so we've seen components, and I think you've seen enough of that. So I'm going to start with something else. I'm going to start with something called the environment. Environment's main task is to map components to hosts. So you list all the hosts that are in this specific environment. This is actually an excerpt for the production environment. And I can tell, well, the Nginx component goes here and the HA proxy component goes here. And I want to deploy a supervisor here and here. That's basically how you assign that stuff. You can have one of those per environment. We usually even have, so we have one for production, one for staging. And usually every developer makes a custom one of those, so that you can arrange whatever part of the system you're working on. You might make a partial deployment and only install the stuff that you actually need. And you can actually also, as we're using Mercurial, specify the branch that should be checked out for deploying this. There's one executable called batou local that is used to realize an individual environment and host combination in place. The place where you're going to call this is your project root, and it's going to create whatever happens. So this one is the output that you get when you have a hello component that defines a file called hello and manages its presence and the content. And as we are convergent, if you run it again, nothing actually happens. The other side is the remoting part. So if we have the same thing deployed to 2 remote machines, then you would actually call batou remote, and you would tell it deploy the production environment, and it connects to this host, and it actually triggers deploying the components over there. That's very simple. Something that it can do is that it actually connects to all the hosts at once, and so this is very simple. If you have a lot of components, then batou will actually go back and forth between the hosts in the right order. So it doesn't work on the host granularity, first going over tester 1, tester 2, but it actually looks at the top level components, how they are connected together, and so it might be going back and forth between 2 or 3 hosts. So if you have a specific component that you're deploying, like the hello component, then you might put in some variable that differs between the various environments. So in your environment config, you can actually put in sections like this and give overrides, and those are going to be stuck before configure is run onto your instance of the component. So it's very easy to say something like, well, the front end name is mywebsite.com only in production, and otherwise it's in staging it's called staging.mywebsite.com, and that's how you actually differentiate that. And that makes it easy to look at the code and ask where are the differences between environments or between components, and all these access are actually quite accessible. Sometimes a lot of times you're going to use secrets. You've got database passwords, you've got SSL certificates, you've got SSH keys. So you can put everything in a file called secret/yourenvironmentname.config and name the section. This is similar to the overrides from the previous slide. And you just put the attribute value thing in there, and it's gonna appear on your instance when it's running. You don't have to do anything, and that's encrypted with GPG, with a multi-key encryption, where you just list all the email names, the email addresses, or the key IDs of the people that you work with, and you can actually control that per environment. You can give different sets of keys for production, for staging, etc., so that you can actually have people working on your system without actually having access to production. Okay, so that's actually currently sci-fi. We're currently doing something else, but I've got the code for this almost working, and I hope to merge this on Saturday. So I don't even want to tell you the old approach. Here's an API thing. There's a small key value store to communicate data between components. This serves 2 purposes. One, it reduces redundancy. You only specify what the address is that your application actually listens on at one place, which is where the application is configured, and then you tell into the environment, I've got a value for app server, and this is always multi-valued. So you just say provide, and the other side, require, gives you everything. And you can actually filter this. You can say, well, give me only the values of the keys from the same host, or I actually expect that only one is there. Then you can say require one, and it errors out if there's multiple. So this helps you also stay consistent with, I've got to deploy this many things and I'm missing something, or stuff like that. And those dependencies, these are the reason why configure may be called multiple times. If batou notices that you require something and later on somebody else provides the same key, it knows, that was wrong. I've got to run the provide first and then the require. So that's why we keep reprocessing the configure stuff. And that also gives batou the information of what the dependencies between your top level components are, in which order to actually deploy them. There's something called platforms. This is useful if you want to add model code that is specific to certain targets. So the flying circus might be different from what you deploy in Vagrant, what you deploy in your OS X, etc., etc. And you don't want to have these big if-else switches in your model code all the time. So what this actually does is it declares that whenever you realize an HA proxy component, then attach this as the last subcomponent to it. And the platform is really just a string. You can spell that in the environment. And the default for that is the target domain that you deploy to. When you run locally, you can always go ahead and say, well, run the production environment deployment here locally by saying batou local production this host. then you can explicitly turn off all the platform extensions so that it doesn't accidentally try to start Apache on your machine. One thing that's also helpful is file system name, file path mapping. If you have a component and it goes somewhere where it shouldn't go, like etc proxy, by default it's gonna allow that. It's gonna just open the file, do whatever it needs to do. But you can, in the environment, specify a sandboxing mechanism for the file system, and the developer option actually moves all the files into your local working area. And the interesting part is that whoever references that file gets updated also, so that all the references to the remapped file still work. I use that a lot on my Mac to deploy stuff like Postgres configs, etc. Because these actually are in a completely workable order after they come out there, and all the other components that reference it still work. And there's another option that where you can provide a set of filters to rewrite paths arbitrarily. Last thing, this is kind of like feature after feature. The last thing that is sometimes helpful is you can specify a list of features that your component supports, and as you know, you can override component definition on an by environment per environment basis, and this is basically the mechanism to override component configuration on a host basis. So in your environment, you can say on host A, I want the my app component, but with the instance feature enabled. By default, all features that you put in there are on, and otherwise, if you start spelling them out, then it's only the ones that you give. This is helpful. This is very, very coarse-grained. This is helpful in very particular situations where you, for example, have a really, really big binary build that you have to do, and on some machines you want one part of it, and on others the other, and maybe both, and then so you can keep them both together nicely. It's not always the best thing to do that, but sometimes this is easier. All right. Whoosh. I hope these were actually exciting features. This is the stuff that are utilities that work together very well, and for me that helps us to actually achieve simple single command deployments. Likely you will not use all of that all the time. I just wanted to give you a broad overview of what's there, so that you could hopefully see something good in there, and maybe it gives you ideas for your own deployments. Before I close, again I'd like you to remember a few things. First, convergence is really good, and it's hard to just write down convergence. You need a little bit support from a framework, and I've shown you one approach to actually do that nicely. Composition helps a lot in there. Divide and conquer, make smaller pieces that are actually understandable, where you can actually predict whether it has convergent behavior or not. And last but not least, and I think all the slides showed you that it's a lot of details. Whatever you do, deployment is going to be a lot of details. There is no silver bullet, and I can't stop you from shooting yourself in the foot. I just hope that you, with this, I hope you enjoy when the pain fades. All right, thank you. Questions, please.
Oh yeah, what's the thing?
Just a small detail question.
Yep.
What are you using for SSH?
Paramiko.
Oh, sorry. I work in the hosting industry, so we do a lot of this kind of stuff.
Uh-huh.
And one of the problems that we run into a lot is partial updates of files. We have our own in-house system for doing stuff like this, and what we use are lenses, for which are a way of describing a file.
Right.
So that you can say, I want to update this part of the file.
Right.
Does
Right.
batou support that?
Not out of the box. I mean, the generic model, you can build something like that.
Mm-hmm.
So lenses are a term, I know that. What's the system you're using?
No, it's an in-house one that we use.
Oh, okay.
Yeah.
There's some open source system that specifically takes care of managing partial files. Using a lot of Puppet on the system configuration level, we generally do something called snippets, where you could use the provide require mechanism, where everybody broadcasts either parts or snippets, and then you have one component that requires all of them, joins them, and flushes them.
Okay.
That would be one approach, and we're doing that actually, yeah.
I assume you'd accept patches to add lenses?
Sorry?
I assume you'd accept patches to add lenses?
Sure.
Yeah?
Sure.
Hi.
Hey.
How do you remove a component from the configuration and how it is handled on the server?
Can I point you back to the no silver bullet?
Sorry?
This is a good question. It's really hard. In general, it's not possible because as you only describe partial system state, if you stop expressing something about something, then you just take your fingers away, right? So you can always make a file where you say ensure absent, for example. But then again, that means you have to over time take out stuff that you unmanaged before, and so I don't have a good idea currently how to generalize unmanaging things. Unmanaging things is really hard. Yeah. Obviously, you can always turn around the definition and say, I explicitly say I don't want this anymore. But I don't. Yeah, that's very mechanical. Hey.
Yeah. So I want to ask if you have like a long-running environment which you deployed and it's like working and you want to make changes to it, but things like, for example, my WordPress is getting like overrun by traffic. I need to add a few more machines for that, or like I need to add a backup MySQL or database or whatever to actually deal with the traffic. How you can do that without tearing off everything and like redeploying it how it should be?
You don't. That's the interesting part. So something you can do is, for example, if you want to add another application server, in the environment you just add another server that says I'm a WordPress instance. The HAProxy config would get notified and then reloaded, but that's for free. HAProxy can reload on the fly. And the other instances, because they don't change, they don't need to know about the one, so their config isn't touched, they aren't restarted. So the only thing that happens is you configure a fresh new node, HAProxy gets reloaded, you're good.
The opposite question, so if you need to take down a host, can you just do it and it will be like taken down? And
Well, what happens if you take it down is you stop managing it, so you delete it from the environments. The HAProxy component notices that that host doesn't exist anymore, removes it from HAProxy, but the node will sit there. I mean, it's going to... But...
And how do you manage updates?
Exactly that way. No different. Exactly that way.
Software update, for example, you have to update a bunch of systems because there's a security hole or whatever.
So that depends a lot, right? So on the system, we don't install system level packages with that. In our environment, I mean, you can do that. In our environment, we have Puppet and a lot of custom code for managing the operating system. So these are for free for us. In here, if we have, for example, so we manage build out a lot. Then you would actually change the build out config in there, add the version, kick it off. It notices that the build out change triggers on build out, notices that the software change triggers supervisor, reloads the thing. So that happens automatically and also only does the things that it needs to do. That's the important part there. One thing, if you're using build out, one thing we learned is split them up in many, many small parts, make many small components with small build-outs. That gives you the freedom of actually using different Python versions, different version pins for every interpreter. We even just blindly generate virtual env after virtual env after virtual env for each Python environment that we put in there.
If you use packages?
Packages?
Yeah.
Python packages or system packages?
System packages like Debian or...
Well, if we expect a system component to be there, for example, in the Flying Circus, we manage HAProxy for you, then we manage it in a way where etc HAProxy is readable and writable by a certain group in the system. So I can tell batou to actually access it because he's run as a service user who has access to that file. But I just assume that the software is installed and that the service is running and that there is a pseudo rule for triggering HA proxy reload. That's how we integrate. This is what I said is the API, the UI between system configuration and service deployment, where I say, I don't want to take care of the operating system and this and this and that. I want you to guarantee me that these things are there so I can just assume them over here. But where you draw the border is completely up to you.
What's the best way to integrate this with Vagrant?
Good question. That's something I want to look into at the sprint. I just learned a little bit I just got used to Vagrant when I wrote the PyPy Vagrant box, the PyPI Vagrant box, and I see that it could be very useful for developers to have something that out of the box is able to deploy batou stuff to. That is something that would be really nice to look at in the sprint. If you want to join me, then you're welcome. Du hast doch eine Frage.
Just a small question. You didn't actually mention on what scale you are actually using this tool yourself.
Dozens of machines. So about, I think the biggest single environment is about 30 machines big. That is, I think we are not far away from the breaking point of SSH. We already see problems when we deploy from consumer grade routers. Having 30 SSH sessions open can quickly saturate the ability of smaller routers that you have at home. We've seen that. A temporary workaround that I'm going to look into is actually using a bouncer to only make one SSH connection to one of the machines on the target and then turn around and spread it over there. The problem is, as I said, creative limitation. I don't want to assume too much on the remote side. I mean, I've been thinking about looking into Salt or ZeroMQ things or something. But then again, suddenly I need a lot more running on the target machines. So that is something where that would be interesting to scale it further.
Current requirements on the target machine.
The current requirement on a target machine is the SSH daemon lets you go into without with a key. It doesn't want a password from you. Python 2.7, virtualenv, and Mercurial.
On which target?
It's not that big. It's relatively easy to achieve. Especially as it doesn't need too much active configuration. I mean, SSH needs to be configured, but Python, virtualenv, and Mercurial just need to be there. You don't need to do anything there. That is an area with a lot of potential for improvement, actually. It's just what works right now.
Parabico supports proxy command now. Maybe that's
yeah. That's what I was thinking about looking into. Yeah.
Any other questions?
All right. There's a couple of links. If you guys want to look at it, then feel free. Also, I'm around at the sprints. And in general, we still have time. I'm surprised there were so many slides. All right, coffee.